right. For those of you who did not get a nice little rubber ducky, there are some extra ones at the front. You just have to sit within spitting distance of me, and you can have those. I'm here today to quack to you about DuckDuckGo, hybrid SQL execution with DuckDB and MotherDuck. But overall, I'm here just to have fun with a bunch of great folks from Brisbane. I am from Boulder, Colorado in the US, and I thank you for your kind welcome to your wonderful country. You can reach me on Twitter there at RYIRG, or connect with me on LinkedIn or anything else. So these things. Centralized compute. For those of you who were around back then from the 1940s to the 1970s, we had these mainframe computers. They really introduced computing to the world, but they were accessible mostly for folks at large companies, wealthy enough academic institutions, and they had goods and bad parts to them. They were powerful. They had this centralized compute. Shared access in this case was good in that it provided some level of equality. If you were at one of these organizations, you could take your program card decks and your punch card decks and take them all over to the operator, and they would give you your results. But they were bad in that they were bulky and expensive and not very personalized. So then came the PCs in the 1970s to 1980s. How many of you had a computer that looked something like this at one point? Your dad did. Thank you. Make us all feel young. I appreciate it. Well, your dad and his revolution popularized computing because he had these computers that were dedicated and personalized. In all seriousness, this represented really a shift, right? From your computer being in this big room that you would go and talk to an operator to your computer being in your desktop. And you didn't need to worry about your work impacting others, which was the important thing. But I'm here to argue that we've shifted back and that the cloud data warehouse is the modern day mainframe. It's a shared environment configured to work best for the operators and the average user, but not personalized for the individual. Yet, as I'm standing here, I have, what I would call a supercomputer, but, I had one of those other ones back then too. It's this, computer with 32 gigabytes of RAM and 10 cores that's relegated to handling a few Chrome tabs. And actually, well, if I'm in Zoom, maybe it's like 99% used, but usually it's about 85% idle. What are we doing here? Why do we have these modern day mainframes up there in the cloud doing all of our data work, yet we're sitting here with these computers that are largely idle? How can we take advantage of them as well? That would be just Ducky, wouldn't it? Come on, that's a good one. All right, so that's what we're here to talk about, is how can we take your laptop and add them into the equation for your data analytics. And I'm going to be talking about DuckDB and largely talking about the open source DuckDB for most of this talk. Then I'll get into a little bit of what MotherDuck does as well. But if we talk about the open source DuckDB, it is an in-process SQL OLAP database management system. The website seems like it was written by academics, not marketers, probably, because it was. The creators of DuckDB are Hannes and Mark here, and they created DuckDB when they were at CWI, or the Dutch National Computer Science Research Institute. They're the ones that maintain DuckDB today, either through the community and foundation work or through DuckDB Labs, which is a consulting company. But this is kind of the origins of what we worked with them on building. And I'll go through more of a relationship here in a bit, but want to give credit to these folks because they're really awesome. And they created DuckDB, even if they might be marketing it better at academics than they are for the average person here. But I will want to explain what each of these things are if we break it down. When we say in process, it runs inside your Python or R or C++ process. There are no external dependencies. It's a 20 megabyte executable, and they even rewrote things like the parquet parsing libraries and such to make it fit into the executable without these external dependencies. So it sits inside your code. It allows you to run your analytics, which I say OLAP here. Someone told me that's old school. Maybe I'm just old school, but I'll say it runs analytics. Full SQL support. They try as best to implement the functionality that is in Postgres, but then add on better support for analytics capabilities. And it does high performance aggregations, which is kind of like the central thing with analytics. So we call it the SQLite for analytics. For those of you who weren't aware, SQLite is perhaps the most widely installed piece of software out there. If you pull out your phone, you probably have 10 copies of SQLite running on your phone. Inside your computer, probably many more. But it's really based off of a transactional model. And we wanted, or Mark and Hannes wanted to do an analytic version of this. And you might ask, where did they come up with this idea? Where did they decide to do this lightweight analytics database? And it really just roots to their belief that databases are awesome and they get confused when people aren't using databases or what they consider real databases. And so they're academics. They are around a lot of researchers who use R at the time and use R to do their data analysis, but they use DataFrames and things like that. They weren't using SQL or a real database. And so they went, Mark and Hannes went to these researchers and said, why? Why aren't you using a real database? And they're like, well, we thought about it. We tried installing some things. It just took forever for us to install and configure them. And then the network latency is too heavy to, talk from our computers over to these database servers, or, maybe we tried doing some VMs and some Docker images, but it was just all too much work. Why can't we just do stuff easily within our R code? So DuckDB was originally created as a way for these data folks in R to run analytics for their academic research. And then more recently, it's become much more popular in the Python community probably than the original R community. But overall, it really came because Mark and Hannes had sympathy or empathy for their fellow academics who were doing this research. So DuckDB has a set of characteristics here around why I think that DuckDB has gotten so popular, why DuckDB is kind of universally loved and hated on the Twitter sphere. And that comes down to how easy it makes things, how fast it makes things, how the community works together, and Mark and Hannes and the rest of the DuckDB Labs folks also work with that community. And then the last one, also very important here, about how quickly they innovate on the core product. So I'm going to go through these things, starting off with the simplified data access. And I'd mentioned the R community and Python community. The reason that Python community got to really love DuckDB, I think, is because of the interaction between pandas and some of the other data science libraries in Python and how DuckDB works. So this code here, you can see, basically we're just creating a vanilla, see if the computer recognizes where I am. That doesn't quite work but anyway, they're just creating a vanilla data frame here. So creating this test df as a data frame from a set of lists and dictionaries, and then registering that data frame with DuckDB, and then you can do SQL on that data frame. So directly within Python, you can run SQL that looks at your data frames, and then the last statement there you can see is actually getting a data frame out as the result as well. So this isn't using any external data, it's just using that data in that data frame, but allowing those folks who know and love SQL to be able to access that data frame using SQL. You can even then take DuckDB and have it access data that is elsewhere on other machines. So in here, accessing over a URL, a CSV file, in fact, a gzip CSV file, and just querying that directly with SQL. And DuckDB is pretty good at this, and you can see my other statement here is taking that SQL and it's taking that CSV and converting it to parquet. So essentially, like, one line to take a CSV file that's sitting out there compressed on the internet and converting it into a parquet file. This is the type of ease of use functionality that the DuckDB folks built, which makes a lot of people really love it. You can do similar things with parquet files, and you can access S3 buckets with credentials, and you'll find a lot of people doing this for ad hoc querying, but also for sort of ETL processes and things like that to make it really easy to transform data between formats or limit down their data sets, et cetera. But really simple, easy to use no matter where your data sits, including even Postgres databases. You can attach a Postgres database into DuckDB, and then query data out of the Postgres database. And in this case, I'm also creating a parquet file from the Postgres database as well. So they really make it easy to access your data regardless of where you're from. So whether you're trying to get data accessed in parquet format or CSV, SQLite, Postgres, et cetera, whether it's local, whether it's remote. And they integrate kind of with the existing environments like you saw with the Python pandas library implementation. And I showed you a really basic version where it is just querying only that pandas data frame, for instance. But you can actually have that be a table and join that against other data sources, whether local or remote, and really just kind of bring everything together and use SQL for that. The one thing I want to emphasize here is the in-browser capabilities. So these are probably more nascent than some of the other capabilities with DuckDB, but DuckDB will actually run in your browser in WASM or WebAssembly. And it's a full copy of the same database that's running elsewhere. And this makes it really awesome to build web applications with full SQL capabilities where you don't have to do all your filtering and stuff like within JavaScript. You can actually use the SQL capabilities. And we use it in the MotherDuck UI, which you'll see a screenshot of later. There's also a number of BI vendors and all that are using it really to make it so if you drag a scroll in Tableau, for instance, you're used to kind of having to get a cup of coffee in between your drags of a scroll bar. We can make that pretty instant here with having a full SQL engine available in the browser. So the other thing, high performance architecture. Basically, it is optimized for your analytics types queries. So Different types of database engines, useful for different types of things. You've heard this message before in earlier talks. Row-based databases like SQLite, very low memory footprint. You just keep a row in memory. Great for transactional workloads. You're often inserting an entire row for a transaction or retrieving an entire row for a transaction, but not very good for analytic workloads. So that's why you have columnar databases. Pandas and NumPy use columnar database structure. It's great for analytic workloads because a column is easy to aggregate. You often don't need all of the columns when you're doing aggregations. You just need one or two. And you can also do really great data compression on a column because it's similar data. Every row is similar to each other. And then DuckDB, as well as a lot of the other platforms that you may use today, have then said, okay, but let's vectorize this. Let's take it and create row groups of these columns and process these chunks, these vectors, simultaneously through SIMD as CPU functionality to process multiple data simultaneously. Let's basically just make it optimized for locality with your CPU. So from a CPU locality perspective, this is again a M1, MacBook Pro, much larger sizes of cache than you would see in other machines, but 2.9 megs, 28 megs, 48 megs, and that's before we get to main memory. The L1 cache is the fastest thing to access. The more data operations that we can do with data that's in the L1 cache, the better. L2 cache, slightly less better. L3, slightly less better. And then, main memory is slow in comparison. So DuckDB really tries to optimize it for these vectors to fit into the L1 cache and sort of pipeline that data into the processor where it can be accessed super quickly. Now, I'm talking a lot about memory, but DuckDB is not just in memory. I've actually met people who have worked with DuckDB for, say, months and not known that DuckDB worked against a disk. They thought that DuckDB had to be used just in memory. Absolutely not true. It has its own native storage format. And you can even do larger than memory queries, and it will spill over the intermediate result sets to disk. And the native storage format is actually pretty cool. It's very similar to other formats that you've heard lately to build upon Parquet with ACID compliant updates like the icebergs and the deltas and such. It is columnar, it is partitionized, all of that's very similar. The biggest difference is that it does store an entire database in one file, not just individual tables. And why is that a difference? Well, it is a difference because they were really looking for portability, the ability to share these data files around with other people in the community. And having a single file makes it a lot easier than sharing some S3 bucket and credentials and things like that. So one of the other areas that they're constantly iterating on is different ways to compress the data. Now, these examples are actually fairly basic, but they do show you the types of things that folks are doing to compress the data inside that data file. So dictionary compression is just look up in the dictionary and just store the index in the dictionary. FSST is a little bit more complicated, where it is storing substrings in the dictionary and then referencing those substrings with indexes. But perhaps the most important thing that this emphasizes is how much change happens in DuckDB. Now, this is an old screenshot, but I think at around v0.6, and you can see between the original version of DuckDB and 0.6 how much smaller the data sizes have gotten over time. And it's something that the DuckDB folks kind of take pride in, keep on shrinking down the size of those data sizes. Because the smaller the data, it's not about the storage, it's about how fast it is to process the data. And if you can bring in the compressed data and bring more of it into memory, the better. With DuckDB, you can actually look at the compression of your data, and it's kind of fun. If you are the type of person that attends a conference like this, it's kind of fun. You can see here, every column basically has at least one different compression algorithm. But then it's also divided into row groups. So depending upon your set of rows in your database, you can actually use multiple different compression algorithms for different row groups. And it really optimizes that for you. You don't actually have to worry about this, but this is just one of those like kind of fun things for database geeks. All right. So it's about normal size data. Some people have come to me and said, hey, DuckDB is for small data or is for medium data or whatever. I swear that the definition of small data, medium data, and big data changes dramatically depending upon where in the world you're from. If you're from Silicon Valley, it's like, small or medium data, a few terabytes here and there. Like if you're into petabytes, that's big data. Many other places in the world have different definitions. But this quote here, the vast majority of the orgs in the world do not have greater than billion row data sets, but need the benefits of data. This is why this gentleman is so excited about DuckDB. And it affords the power of an expensive cloud data warehouse without the complexity. I think without the complexity is the part that I like about this most. But I also think that larger than normal size data also happens to work perfectly fine in DuckDB. And this is from Mim, who's kindly in our audience here and a speaker today. The irony of life, I've never done a query on a billion row table, but when I did, it was on a laptop using an in-process database. So DuckDB works with those billion row tables too. In fact, some of the queries that I'm going to show you here are using a 1.5 billion row data set, starting off by just doing it on my laptop and saying, okay, I'm going to query these parquet files and get the average distance from these parquet files of basically taxi data. So the average trip distance. It took about 2.95 seconds, 1.5 billion rows. And these are from these parquet files. I can load that data into DuckDB and get it a little bit faster, also returning that result, but still 1.5 seconds on my laptop, querying 1.5 billion rows. And you can get it down a lot smaller if you use the benefit of the cloud. This is vanilla DuckDB open source on each of these machines. I probably should run these again because there's been a couple releases of DuckDB since I did, and it probably has improved a lot. But so we have high performance, we have ease of use. We also have an open source community that is, been very supportive of DuckDB. These are the GitHub stars. This is the DB engine ranking. And there are 240 contributors to the GitHub project, 3,500 members of the Discord. There's a newsletter done by the community, but hosted by MotherDuck, almost 4,000 subscribers there. So it's a very vibrant community that is excited about DuckDB. One reason they're excited is how quickly they innovate. I'm not going to actually go through line by line of this, but these are a couple different releases separated by 3 months, and what happened in 0.6, what happened in 0.7, and 0.8. They keep on pushing things out. And I would say that, Mark and Hannes will see something in an academic paper and within days to a week have implemented that in DuckDB and gotten it into the next release, which is why we're super excited about it. Plus, Mark looks pretty funny with his pet duck. This is Wilbur, who's Mark's pet duck or former pet duck, and what DuckDB is named after. You're probably wondering, though, what the heck is MotherDuck? Why is this guy up here in this crazy duck shirt talking to me about just open source DuckDB? What is MotherDuck? MotherDuck is a venture-backed startup. Basically, data geeks from across the industry got together and said, can we use this DuckDB technology to make it easier for data analysts to do their job? And that's what we're on our venture doing. Mark here had a perfectly honest question of why are we using the cloud? Isn't DuckDB great for local? Why do we care about the cloud? There's a lot of things that you can do, collaboration and scalability and things like that in the cloud, but we still truly believe that your laptop can actually be complementary to that, not replace it. So we've asked ourselves, what if query plans could decide whether to bring the compute to the data or the data to the compute? And built this, what we call hybrid querying architecture, where a copy of DuckDB runs locally in the client as well as runs on the server. Your client actually determines the query plan, determines which segments of the query to send off to the server, which segments of the query to process locally. And this is a quick little view as to how this works. This is, again, the taxi data. And we have our taxi data that is out there on the server. And we want to join our taxi data to a local lookup table that's on our laptop as a CSV file. We can include that in our DuckDB query. And then the SQL planning engine basically says, okay, some parts of this are going to go remote. Some parts of this are going to go local. But we're going to join it all together and get your result as if the query was all executed in the same environment. So MotherDuck has a nifty web UI, which does that as well. So if you get a result set back in MotherDuck, that result set is available in a local DuckDB instance, and then your sorting and filtering and all happens in DuckDB. So features, the primary thing is if it can duck, it can MotherDuck. It's really easy. You just say MD : as your database name instead of your database file name, and that will use DuckDB. That will use MotherDuck if you have an invite. And I handed out a bunch of invite cards. If you want an invite card and didn't get one, there are some in the front row and such, or come to me. But letting you folks into MotherDuck, it's invitation only at this point, but let's get the Brisbane community going. And I have 30 seconds left before my friend here is going to kick me off the stage. So I'm just going to say, hey, we're really about make your laptop your personal analytics engine, but also scale into the cloud. One use case really is how do you take your local development environment and push it to production? And we're seeing a lot of that, and you can do that with DuckDB and MotherDuck. And if you want to learn more, motherduck.com, and you can find me on Twitter here. So I think that is perfect timing. Well, maybe 2 seconds over, but thank you very much. And I'll be around this afternoon and the evening if you have any questions.
Duck and awesome. Thank you.